Good morning, students. In the today's session, we'll learn about what is meant by congestion, okay, as well as quality of service, okay. Now, first we'll start with what is meant by congestion. Let me see here, whenever if we have a transmission of data between the client and server. Here we have a transmission of data between the client and server. Especially the main task of the transport layer is for the transmission of data. There at the transmission layer, we have the connection oriented service, connectionless service, and the packets will be transmitted. All these things will happen. But here at the transmission side, if the congestion occurs, what is mean with this congestion? Here in a network, it may occur if the load on the network is greater than the capacity of the network. Okay. And here for this here, if the load of the network, okay, is less when compared to the capacity of the network. Okay. That means here the load is more and the capacity of the network is less, then only the congestion will occur. Now here, what is mean by this congestion control? That means this congestion control is a mechanism. Okay. We can also call it as a technique to control the congestion and keep the load below the capacity. What are the three we have to follow? Now, first one is what is load. It refers to the number of packets sent to the network. What is meant by this capacity? It refers to the number of packets a network can handle. Okay. And next, what is meant by this congestion control? Here we have the first, the delay and load. Here, now the congestion control involves two factors that measure the performance of a network. One is delay, okay, or throughput. One is the delay. Here the load is much less than the capacity of the network. Okay. Then the delay is minimum. The minimum delay is composed of propagation delay and processing delay. Now, when the load reaches the network capacity, then the delay increases sharply due to its additional waiting time in the queue will be added to the total delay. Now, the delay becomes infinite when the load is greater than the capacity. When a packet is delayed, the source that is not receiving the acknowledgement will retransmit the packet. This makes the delay and the congestion even worse. Now, what is throughput versus load? Throughput means what? Here in a network, it is defined as a number of packets passing through the network in a unit of time. The load is below the capacity of the network and the throughput increases the proportionally to the load. When the load exceeds the capacity, then the queues become full and the routers have to discard some packets. Okay. Now, the discarding packets does not reduce the number of packets in the network because here the source retransmit the packets using the timeout mechanism. Now, what is mean by this congestion control in TCP? Here, this TCP is going to maintain the congestion control mechanism to avoid the congestion or alleviate the congestion in the network. First one is what? Congestion window. That means in the TCP, the center window is determined by the available buffer space at the receiver. That means the receiver dictates the sender about the size of the center's window. If the network cannot deliver the data as fast as they are created by the sender, then the network must tell the sender to slow. So the network can also determine the size of the sender's window. Now here the actual window size is equals to minimum of here this receiver window and congestion window. Okay. And here the sender window size is determined by the receiver and the congestion in the network. Now what is mean by this congestion policy? There are three phases in TCP congestion policy. One is a slow start, another one is congestion avoidance and the congestion detection. What is mean by this slow start? It is exponential increase. In this algorithm is based on the size of the congestion window. It starts with one maximum segment size. The maximum segment size is determined during the connection establishment by using an option of the same. Here, the size of the window increases one maximum size. Okay, each time. Then an acknowledgement will be received. As the name implies, the window starts slowly by growing exponentially. Now here, what is meant by this congestion avoidance? when the size of the congestion window reaches the slow start threshold. Then the slow start phase stops and the additive passing phase begins. Now, in this algorithm, each time the whole window of the segment is approached, the size of the congestion window is increased by 1. Now here it is a first round of transmission. Here the congestion window is 1. Then it was added to 2. Then it was added to 3. Then it is added to 4. One after the other, the congestion window is going to be increased, means automatically the size will increase. Here, consider the above example that implements the additive increasing algorithm. That means it is going to, if the number of packets are more, automatically the window size is increasing. Okay. Now, what is mean by this congestion detection? Here it is also called as multiplicative decrease. Now, if congestion occurs, the congestion window size must be decreased. Now, when there is a need to retransmit the segment, then the sender gets that some place the congestion has occurred. Now, what is mean by this retransmission? It can occur in one of the two cases, when a timer times out or when 3 acknowledgements are received. Now, in both cases, the size of the threshold is dropped to 1/2 a multiplicative decrease. Now, here, this TCP, here it is going to implement, this TCP is going to implement 2 reactions. One is the, here, if a timeout occurs, there is a stronger possibility of congestion. A segment has probably been dropped in the network and there is no news about segments. And in this case, the TCP reacts strongly. It sets the value of the threshold to 1/2 of the current window size. And here the current window size to the size to 1 segment. That means here we are detecting. Now it starts with the slow start phase. Okay. Now here if the 3 acknowledgements are received, there is a weaker possibility of congestion. Because here the acknowledgements are receiving one after that, that means the congestion will also decrease. A segment may have been dropped out, but some segments after that may have arrived safe. Since the 3 acknowledgements are received, this is called fast transmission and fast recovery. In this case, the TCP has a weaker reaction. It sets the value of the threshold to 1/2 of the current window size, and it sets the current window size to the value of the threshold, that is current window size equal to S threshold. Okay, and it starts the congestion avoidance phase. Okay, see you in the next session about the quality of service.